Correlations do not prove causality. They acknowledge that X and Y are related, but don't explain why they are. There can be correlation further tests that can be done to try and find the causation. Pearson's product movement correlation coefficient test is a parametric test to find the R value of a set of data. This determines the strength and direction of the correlation, the relationship between two sets of data. The data is paired data, so comes from the same participants. It is a parametric test because the data is normally distributed. Once the R value is calculated, you then have to compare this to a critical values table to determine whether the R value is significant or not. If the R value is greater than the critical value, then there is a significant relationship. Dependent on the hypothesis the researcher has stated depends on the column that the researcher should use in the table of critical values. Shown in the next slide is the critical values table. Whatever hypothesis the researcher used, they would always use the standard level of significance, which is that P has to be below 0.05. Once I had the initial calculation shown above in figure 32, then I broke it down into smaller calculations. I calculated 8 multiplied by 538, which equaled 4,304. Following on from this, I did 57 multiplied by 71, which gave me 4,047. Then I took the 4,304 and took 4,047 away from that to give me 257. So I had calculated the top number. Then I calculated the bottom half of the equation. So I did 8 times 507, which gave me 4,056. I did 4,056, take away 3,249, which gave me 807. Next, I did 8 times 685 to give me 5,480. Then I took the 5,480 and subtracted 5,041 from it to give me 439. Then I multiplied 807 times 439 to give me 354,273. Then the square root of that number was 595.2083669. So then the top half of the equation, that value, so 257, divided by 595.2083669, gave me the R value of 0.43, rounded to 2 decimal places. So I followed the equation step by step and fitted in the numbers that I'd already calculated in figure 31 just into the equation to give me the R value of 0.43. We always use 0.05 as a level of significance, as it is the standardized measure of significance. The DF allows us to determine the level of significance, as if the calculated R value is greater than the critical value, then it is a significant relationship. The DF is the degrees of freedom. The degrees of freedom allow us to see what column the researcher will use to see the critical value. The degrees of freedom is the number of pieces of independent information that is in a dataset. In this example, we used a two-tailed non-directional hypothesis, as we stated that there could be a significant relationship or there wouldn't be. We weren't committed to either one. So to calculate the DF, you took the number of participants in the research. So in this case it was 8, and then you subtracted 2, which equals 6. So we look down at the DF column and we can see the critical value is 0.7067. Therefore, there is no significant relationship between the bicep and tricep skinfold calipers because the R value is not greater than the critical value. Next is the Spearman's rank order test, which is a non-parametric test for correlation. This is when the data is not normally distributed. You would use this test if you had covariables from the same data. So the data is from two data sets, but from the same participants. This test determines the R value from ranked data. Therefore, this test uses ordinal data only. Once again, once the R value is found, it is compared to the critical values table. So if the calculated value is greater than the critical value, then the finding is significant. If there is duplicated data in the dataset, then the researcher would take what the rank values would be from the set of data, then add up the rank values and divide by how many values that were duplicated. Shown in my example in figure 35, I'm ranking the scores as 10 being the lowest time and 1 being the fastest time. And as there was a duplicate in the rankings, I added the rankings up and then divided them by how many rankings were the same to give an overall ranking. So shown in figure 36, once I had my initial calculation, I broke it down to work out the R value. I calculated the top figures, which was 1,371. Then the bottom values equaled 990. So then 1,371 divided by 990 equaled 1.384. Then 1 take away 1.384 equaled negative 0.384. So I calculated the DF so that I used the correct column when finding the critical value. Like the first correlation test, I will use the standard level of significance, p-value below 0.05. As shown on the critical values table, there was no significant relationship or correlation, as the calculated value is below the critical value of 0.74. The R value was negative 0.84. Therefore, there's no significant relationship between static and flying sprint times.